Hi, this is Lauren Delgado from Vassar College, and now we're going to try a do-it-yourself for motion in a straight line. A person standing on top of a 100-meter high building throws a ball straight up in the air with the velocity of 20 meters per second. How long does it take for the ball to hit the ground? Now pause the video here and see if you can write down any knowns given the previous information, and write down what you were trying to find as well. Now, check yourself. Did you get what I got? So the knowns that we do know from the problem are that the initial velocity, and we're choosing that this is going in the positive direction, is 20 meters per second. And we also know that the acceleration due to gravity is negative 9.8 meters per second squared. And in addition to that, we also know that the initial height, which is denoted by y naught, is 100 meters, and that the final height is 0 meters because the ball hits the ground. So we're going to solve this problem using the quadratic formula, which you might need to pull back a little bit in your memory to remember. But let's see if you can write it down based on memory on the next page. Now, were you able to find this? If not, it's alright. What's more important is that we know how to rearrange the projectile motion equation in order to substitute in the values that we find there into the quadratic formula. So why don't you write that equation and we'll continue forward. Now, were you able to find that equation? I hope so. Now we can put in the values of the knowns that we were given. So 0 equals 100 plus 20t minus 4.9 t squared. We can rearrange that to make sure that this value here is positive. So let's do that. 4.9 t squared by shifting it on the other side of the equal sign. Minus 20t minus 100 equals 0. Now we can make these values become a, b, and c. And when you do that, you find the time. So let's see what time you find. T equals 7 seconds. Now, this is a more inefficient method of solving this problem. So now we can try using formulas that we learned in physics, intro physics, to solve this problem a little bit more practically. And let's see if you can remember those two formulas. You might only know one of them, but let's pause and go to the next slide and see if you know them. Now, were you able to write both of these? Well, each are very important because the first one, as you can tell, we can use the knowns given, put those values in, and we can solve for the v final, which does come out to be negative 48.6 meters per second. And then knowing that, we can find the time by plugging it in here. So negative 48.6 equals 20 plus negative 9.8 t. And with that, we will again find that t comes out to the same value that we found before with the quadratic formula. But this is a lot more simpler, a lot more direct, and this is an easier way maybe to get to that final answer. But both methods do work in solving a problem like this.